Hey everybody, this is Mr. Beckstrom again, and today we're going to be talking about measures of dispersion. This is Chapter 6, Section 3. This is mainly going to be dealing with standard deviation and a little bit on the coefficient of variation. So let's get started. Alright, let's first talk a little bit about the range of a data set. That's really the difference between the smallest and largest data values, and I can find that by taking the largest value from a set of values, which in this case would be 22, and subtracting the smallest value, which is 2. So my range would be 20. Alright, let's define and talk a little bit about standard deviation. What is standard deviation? Well, it's a way to measure the distance of values from the mean. It tells us how far our data values vary from the actual average of those data values. So the closer they are, the more consistent those data values are, and the smaller that standard deviation is going to be. Whereas the more that those values vary, the greater the standard deviation is going to be. A good example would be thinking about like an Olympic 50-yard dash and an open marathon where anybody can enter. So in the 50-yard dash, your values are going to be really close together. So maybe all the values are within 5 seconds and 5.3 seconds. So your range there would be 0.3. That tells you that you're going to have a really small standard deviation since they're very consistent scores. But now let's say we actually looked at the data from an open marathon where anybody could join. So you could have people that walked the entire marathon, and you could actually have Olympic runners that go there and nearly sprint the entire marathon. So you're going to have a much wider range of values that are going to be much farther away from the mean. And in that case, you're going to have a much larger standard deviation. And this formula here is much easier to perform it in steps using a table, which we're going to do. Let's talk a little bit about what these symbols mean. The X is each one of your data values. The X with the bar over it, that's your mean. This is squaring that deviation. And then this says that we're going to sum each of these squared deviations. So for each data value you have, we're going to figure out this value, and then we're going to add it to all of those values. So if we have 10 values in a data set, we're going to perform this operation 10 times and add all of those together. This is what this symbol means. It's an uppercase sigma. And on the bottom here, the n is the size of your sample. So if we have 10 values, n would be 10, and then you just subtract 1 from that and divide your original total by that n minus 1, and finally you're going to take the square root of that value. So let's get started here. Well, let's actually talk a little bit about the coefficient of variation first. So the coefficient of variation is defined as the standard deviation divided by the mean of a data set times 100%. And what that does is it gives us a comparable value that we can use to compare two different data sets. So when I talk a little bit back about the Olympic run and the open marathon, we can actually take both of those and get a certain percent that shows us how far those values vary from the mean, and we can compare two sets even if they're not very similar. Even if they have a much different sample size and they have a much different average, we can still compare those two sets. So suppose we have two sets, one with a 4.2% coefficient of variation and one with a 7.3% coefficient of variation. What we can do is we can say that the set A is more consistent. There's less variation among the actual values, whereas the set B is less consistent. There's more variation in those values. The values tend to drift farther away from that average. Alright, so example 1. What is the standard deviation of the following values? which is asking generally how far do the values deviate from the average. So I gave you 7 values here, and we're going to go ahead and just do this together in a table, and so we can see what we're doing. Alright, so the first thing I want to do is I want to figure out my mean. I just add all those values together, and I divide by the number of values, which is 7, so that's 35 over 7, which is 5. Next, I'm going to set up a table here. I'm going to list all the data values. And the first thing I'm going to do is I'm going to find the deviation between the data value and the mean. So I did those calculations on here, so you can see what I got. I got a negative 303 all the way down to negative 2. And next, I'm going to square those results from the previous column. So I take this result here and I square it. And notice I get all either positives or zeros. I'm not going to have any negatives after I square a value, because a negative times a negative is still a positive. And this is important because we're really trying to look at the distances away from the mean. And if we used both negative and positive values in this variation, then a lot of those are going to cancel out, and then we're not going to know anything about how far it varies from the mean. So that's why, one of the reasons why we square that deviation. Then we're going to add up all those square deviations together, and I get 28. That's 9 plus 9 plus 1 plus 1 plus 4 plus 4. And I'm going to use that for the top of my fraction in my standard deviation formula that you see here. So this value up here, this entire thing, is going to be a 28. We already said we had 7 values, so n minus 1. 7 minus 1 is 6. So my my variance, which this is the value that we get before we take the square root, is going to be 28 divided by 6, which is 4.67. And then lastly, we're going to take the square root of that, because we just found this value here, and we're going to get approximately 2.2. Remember, we round to 1 decimal place beyond the least precise original value, and the original values were all rounded to the ones place, so this is rounded to the tenths place. Alright, so find the standard deviation of the frequency table. Well, really, what a frequency table is at least it lists each individual value and then tells you how many times that value occurred. So if these are my original values, this is how I would put it on a frequency table. So my 6 occurred twice, 7 occurred once, 9 occurred 5 times, and it kind of makes the formula a little bit less, because I don't have to do all 9. See, 1, 2, 3, 4, 5, 10 of those operations. I can just do it 4 times, but I have to do the frequency in there. Now I'm going to show you what I mean here. Just a moment. So, what do we do here? Well, we're going to use this slightly modified formula here. So what we're going to do is we're going to multiply that squared deviation by the frequency before we sum all of those together. And that's the only difference between doing a frequency table and doing a normal table for normal standard deviation. Alright, so here's our table. So here's my 4 unique scores. Here's my frequency, the number of times those occur. And here I'm just finding the product. This tells me the data value times the frequency, and I'm just using this to help me get my mean, because if I take all of these values out together, I get the total of all of my scores divided by the number of scores. So 80 divided by 10 is going to give me an 8, which is going to be my mean. So now I'm going to go ahead and find my deviations. So that's going to be my score minus my mean, which should be a negative 2. And 7 minus 8 is negative 1. 8 minus 8 is 0. And 9 minus 8 is 1. And then the next thing I'm going to do is I'm going to square those values, which I did just right here. And then I'm going to multiply each of those values by the frequency. So I get an 8. So 4 times 2 is 8. 1 times 1 is 1. 0 times 2 is still 0. 1 times 5 is 5. And then I'm going to add all of those together to get the top of my fraction there. So I get a 14. So a 14 is going to go up here. Remember, I had 10 values. So I'm going to divide that 14 by 9. And then I'm going to take the square root of that. And I should get approximately 1.2 rounded to the first decimal place. All right, example 3. Men in Mr. Beckstrom's statistics class have a mean height of 68 inches with a standard deviation of 2.2 inches. The women in Mr. Beckstrom's class have a mean height of 65 inches and a standard deviation of 2.1 inches. We're going to use coefficients of variation to determine whose heights have less variation or whose heights are more consistent, closer to the mean. So take a second, use that formula for coefficient of variations, and then take a look at what you get. Now these numbers are actually really close to each other, and I actually had to go out another decimal place just to compare them. So we went out to the 100th place. So I find that the coefficient of variation for men is going to be 3.24. The coefficient of variation for women is 3.23. So the women have a smaller coefficient of variation, which means that their heights are actually slightly more consistent than the men's. And there's less variation. All right, well, that's it. Once again, if you have any questions, feel free to either shoot me an email or give me a call during my office hours. And we'll look forward to seeing you next time. Thank you.